The greatest common factor, grouping, and the AC method take care of most of what we need as far as factoring. However, there are a couple of special cases that are only going to be done, factored, by having a formula. In this video, we're only going to have one of those cases, what we refer to here at the top as the difference of squares. We need a factoring formula that will work, which means that what we can actually do is go back to our multiplication, pull a formula that we didn't necessarily have to use, turn that formula around, and what we create here in this starred formula at the top of the screen is this difference of squares factoring formula. A squared minus b squared would be factored as parentheses a plus b, parentheses a minus b. So when we see a binomial, we're going to check and see if it is a difference of squares. That means starting out, difference, it has to have subtraction in the middle. X squared minus 4, it has subtraction in the middle, so I'm good with half of my requirements. The other half has to be squares, meaning the first term is some sort of square and the second term is some sort of square, which means that we were asking ourselves, what do we square in order to get the first term? What do we square in order to get x squared? Well, x. So x goes at the front of each set of parentheses. What do we square in order to get 4? A 2. So 2 goes at the back of each set of parentheses. One set of parentheses gets a plus sign in the middle, the other one gets a minus sign in the middle, and so the squares part all works out hunky-dory. For this other example, difference of squares, difference, check. Squares, let's see. What do we square in order to get a 64? 8. So we are going to start each set of parentheses off with an 8. What do we square in order to get a squared? A. That question answers itself. What do we square in order to get b to the power of 4? Well, that's a b squared. What do we square in order to get the second term, which is a 1? Well, that's a 1. One set of parentheses gets a plus sign in the middle, the other one gets a minus sign in the middle. And if we actually FOIL that out, we'll see that everything does work out to give us the original binomial that shows up. Just a comment, there is a second way of thinking about how you would come up with the parts of your factors. And that would be, instead of asking the question, what do I square to get? You could more shortly just say, what is the square root? Square root of 64 is 8. Square root of a squared? A. Square root of b to the power 4 happens to be b squared. Either way, you are getting across the same idea and getting the necessary pieces that allow you to build your answer. If you do not have a difference, then our formula will not work. If we have a difference, but we start asking about squaring things and those questions break down on us, then the squares part of the formula would break down on us and we wouldn't be able to get an answer. We're not going to discuss any of the other factoring formulas that help us take care of binomials, though there are some. They would be saved for a higher level of algebra than what we're dealing with here. Just to mention, yes, those other multiplication formulas that we had previously can be turned around and made into factoring formulas. So you can remember these formulas and use them if you'd like, or you can just simply choose to, as you see, since we have 3 terms, you just go ahead and use the AC method to take care of those, even though they are arguably special circumstances. Most importantly, though, if we're not told what method to use, how would we know which way to factor a particular problem? And worse yet, what if there's more than just one method that needs to be used to completely factor our expression, completely factor our polynomial? Talk about a factoring checklist here, which basically just goes through in the order that we had discussed things, starting with, when we see a problem, can we factor out a greatest common factor, or do we see one of those binomials that we can just go ahead and yank out to the front? If there is a GCF or binomial type of GCF, pull it out to the front. Get that over and done with. Then look at what you have left. Whether you answered yes or no to this first question, look at what you've got left. And however many terms we have dictates what method to try. So if we have 4 terms, we're going to try to factor by grouping. If we have 3 terms, if we have a trinomial, we're going to try the AC method. And if we have 2 terms, if we have a binomial, then we're going to try a special factoring formula. And for our purposes right now, the only formula would be that difference of squares factoring formula. There's one other issue to remember. Just to make sure that you don't stop your factoring too soon, make sure that you ask yourself whether any of the things that you've come up with can be factored more. You don't want to stop too soon. As always, you don't want to go too far either. You need to find that just right sweet spot where you've got everything factored as much as possible. Remember this, ask yourself whether any of the results that you've gotten can be factored anymore. And that will hopefully allow you to catch anything so that you do not stop too soon. So, if we're told to factor 36x to the power of 3 plus 24x squared minus 32x, the directions simply say factor. We don't have any hint, we don't have any indication automatically of what we should try to do in order to get our answer, in order to factor this. So, without that hint, use your checklist. So, starting with step 1, is there a greatest common factor when we're looking at the terms in this polynomial? So we look at the numbers first, 36, 24, and 32. The smallest of those numbers is 24. 24 does not go into 36, so that means that we're going to need something else, and it's going to have to be smaller than 24. So we start considering the numbers that would go into 24, and we'd like to work from the bigger ones down to the smaller ones. So if we think about the 24, then breaking things apart, we could have a 2 and a 12. Let's check the 12. 12 goes into 36, but it doesn't go into 32. Okay. 24 can also be broken apart as a 3 times 8. Let's try the 8. 8 goes into 36. Nope. So we'll take that 24, break it apart again. 4 times 6. Let's try the 6. 6 goes into 36. Yes, 6 doesn't go into 32. Okay, well, we've actually done enough to break up the 24. We've got from the 12, nope, to the 8, nope, to the 6, nope. So we go down to the 4. 4 goes into 36, 4 goes into 32. So 4 will work. Took a little while to get there. The variable stuff, quicker to accomplish. I look at the variable stuff and ask myself, what's the smallest power that shows up? Well, it's the invisible power of 1. So we have a 4x as our greatest common factor. And that means that what we've got going on is when we break off the 4x, we need to know what's left over because we're going to be wondering if there's more to do with that. So if we break off that 4x, we're going to be left with a 9x squared plus 6x minus 8. So in our second step, when we worry about how many terms there are, what we're going to be looking at is the 9x squared plus 6x minus 8. We have, nice job, not 2, but 3 terms. So we're going to try the AC method. The AC method either will work or it will not work. If the AC method does not work, then I have my final answer already. But if the AC method does work, then I'm going to need to know how the 9x squared plus 6x minus 8 would be factored, how it would be broken apart, because those would be pieces of my final answer instead. AC method starts with identifying the A and the C. The A is the number from our squared term out at the front, and the C is the number at the end, and it is just a plain old number in this case, so a negative 8. That means that we've got a negative 72. We need 2 numbers that will multiply together to give us a negative 72, but will add up to give us our middle number of 6. So we go through our different possibilities. And in fact, if you'd like to do so off to the side, let's say first of all that we make a comment that we have 1 negative and 1 positive as far as the numbers that we're going to be coming up with. And we go through those possibilities. 1 and 72 are too far apart. 2 and 36, still too far apart. 3 and 24 are still too far apart. 4 and 18, still too far apart. 5 doesn't work, but 6 and 12, there we go. As long as the 6 is a negative and the 12 is a positive, then we've got the numbers that we would need. So we go ahead and take those and put them into the middle. Each of those special numbers gets the variable from the middle term that originally showed up. That gives us the 4 terms that we need so that we can work through our grouping steps. Group the first pair of terms. Group the second pair of terms. Put a plus sign in the middle. Look at each of those as its own separate problem so that we would have a 3x that we can pull from the first set of parentheses and get a 3x minus 2. And we would have a 4 that we can pull from the second set of parentheses so that we get a 3x minus 2 again. And we would come up with a 3x minus 2 in parentheses and a 3x plus 4 in parentheses. And this would mean, let's just move this stuff out of the way a little bit here so that we can have enough room to write down our final answer. Our final answer for this problem has to have the greatest common factor that we figured out at the very beginning, as well as the factors that came from using our AC method, what we had just finished up. So we need all of those in order to have everything correct in our final answer, everything factored as completely, as fully as possible. If we check things, that is more complicated, but basically we're going to reverse what we've done. So we would take care of any foiling, foil that bad boy out, and then make sure that we get the 9x squared plus 6x minus 8. And then we go ahead and distribute the 4x to make sure that we get back to that original polynomial. And we do. When we look at the problem that the multiplication problem that we've created, when we consider the factors that appear, I'm not going to break the 4 up anymore, so that's fine. The 3x minus 2, I can't do anything more with that. None of my factoring methods will be useful there. And none of the factoring methods would be useful for the 3x plus 4. So there's nothing more that we could do to factor this. This is as far as we can go. We didn't stop too soon, and we didn't go too far. Another example for a little added variety. Factor 81m to the power 4 minus 1. In this particular case, when we look at first for a greatest common factor, there is not one. When we worry about our second question, we have here two terms. So we are going to try the difference of squares formula, which means that we are going to recognize first that we have a difference in the middle, and then move on to the squares part so that we ask ourselves, what do we square to get 81? That's 9. What do we square in order to get the m to the power 4? Well, that's m squared. What do we square to get the second term of 1? Well, that's a 1. And one set of parentheses gets a plus sign, and the other one gets a minus sign. Notice that we still have that reminder at the very top of the screen that just because we've done a little factoring doesn't mean we're done yet. We're not necessarily completely finished until we look at what we have and ask ourselves if there's any more factoring that can be done. That has two terms. Is it a difference of squares? Nope, not a difference. So looking at that first set of parentheses, we could say that the 9m squared plus 1, if we're trying the difference of squares formula again, this is not got a difference in the middle, so there's nothing more that we can do with the 9m squared plus 1. What about the other factor that we've come up with, 9m squared minus 1? Well, we're also going to be looking at two terms, so we would be trying the difference of squares formula. Do we have a difference? Yes. What about the squares? Let's check it out. What do we square in order to get 9? Well, that would be a 3. What do we square in order to get m squared? That would be an m. What do we square in order to get a 1? Well, we already said that would be a 1. And one set of parentheses gets a plus sign in the middle, and the other one gets a minus sign in the middle. So what we've got between these red and pink statements ends up being what we need to create our final answer. Since we can't do anything more with the 9m squared plus 1, that is part of our final answer. Our comments in pink allowed us to come up with the 3m plus 1 and the 3m minus 1. So those would be part of our final answer as well. I cannot do anything more with the 3m plus 1. I cannot do anything more with the 3m minus 1. So I have still considered that possibility. Can I do any more factoring? No, I can't. You go ahead and commit to my final answer. Again, in order to check things, basically I'm going to reverse my way through the work that I've done. Start with the pink stuff, foil that together. Do I get the 9m squared minus 1? Sure do. Take that and multiply by the 9m squared plus 1 and make sure that that foils out to give me my original polynomial, which it does, so I can be confident that I have not stopped too soon nor gone too far and have the correct answer. So the factoring checklist, as you can see from these two examples, helps me work my way through any of my factoring problems in the event that I do not have any sort of hint whatsoever about what to try. And also in the event that, like our earlier example, we have more than one type of factoring to work out. Like our second example, we have more factoring to do, even though we started with a little bit. We don't want to stop too soon. We don't want to go too far. We don't want to forget anything along the way. The factoring checklist is going to help make sure that you avoid those kinds of common mistakes and get the completely factored final answer that you need.